Next, we will discuss how to integrate the products of powers of secant and tangent. Previously, we learned that the general antiderivative of secant x tangent x is secant x function. But is it easy to integrate a product of any power of secant and tangent? The goal is to fill in this gap and develop the methods for integrating all such functions. Let's consider the following example. We rearrange the integrand by chipping away a secant squared function to create a recognizable pattern. Then we set up the substitution by setting a new variable, let's say t, equal to tangent x, and finding the differential of t. Next, we plug everything into the original integral, and because of the discovered pattern, we have nothing but the function of t left in the integrand. We finish the process by finding the antiderivative and plugging the original function tangent x back for t. Notice that the reason that this technique worked was that we had an even power of secant, which allowed us to split the product into a recognizable pattern. Are there other patterns? Let's consider the following example. We can rearrange the integrand by chipping away a secant x times tangent x to create a recognizable pattern. Then we set up the substitution by setting a new variable, let's say s, equal to secant x, and finding the differential of s. Next, we plug everything into the original integral, and because of the discovered pattern, we have nothing but the function of s left in the integrand. We finish the process by finding the antiderivative and plugging the original function secant x back for s. Notice that the reason that this technique worked was that we had an odd power of tangent, which allowed us to split the product into a recognizable pattern. We already considered an example in which the power of secant was even and an example in which the power of tangent was odd. Let's consider the following example in which the power of secant is odd and the power of tangent is even. We're going to use a trigonometric identity to replace the tangent squared with the secant squared minus 1. After distributing, we can integrate each part separately, and we get the final answer after combining the like terms. When the power of secant is even, we can use the split and substitute technique in which we rearrange the integrand by chipping away a secant squared to create a recognizable pattern. Then we set up a substitution by setting a new variable, let's say t, equal to the tangent x, which leads to a simpler integral of a polynomial function in terms of t. When the power of tangent is odd, we can use the split and substitute technique in which we rearrange the integrand by chipping away a secant x times tangent x to create a recognizable pattern. Then we set up a substitution by setting a new variable, let's say s, equal to the secant of x, which leads to a simpler integral of a polynomial function in terms of s. When the power of secant is odd and the power of tangent is even, we can use the trig identity to replace the tangent squared with the secant squared minus 1, turning the original integral into a linear combination of the simpler ones. We discussed the integration techniques for integrating the product of powers of secant and powers of tangent.